questions 11 through 20 on the 2011 grade 10 AMC 10A. Square EFGH has one vertex on each side of square ABCD. Point E is on AB with AE equal to 7EB. What is the ratio of the area of EFGH to the area of ABCD? Let's first draw a little diagram to talk about what this means. So here's our big square, and then they've got another square somewhere in here. So let's see if I can draw that in. So something like that, right? It's not perfect, but you guys get the idea. All right, let's label this. So we got A, B, C, D, and then the one that is on a slant, that is E, F, G, H. And then they tell me that right here, that AE is equal to 7EB. So that means, for example, is if EB is X in terms of its distance, then AE from there to there will be 7X in terms of its distance. Okay? And because of the symmetry of this diagram, this is also 7X, and this is X, and all the way around it's the same thing. 7X, X, and so on, right? So we can first easily calculate this EF because that will be needed to figure out the area. So using Pythagoras, EF squared is equal to EB squared, which is X squared, plus BF squared, which is 7X squared. So we got X squared plus 49X squared, and that is 50X squared. And that is pretty much going to be the area of the square, right? Because the area of the square is EF squared. That's how you find the area of a square. So that's good enough. And then the area of ABCD, that one is going to be obviously just one full side squared. One full side is 8X. So ABCD, the area. And that is, of course, 64X squared. So now they want the ratio of EFGH to ABCD. So that is 50X squared over 64X squared. And that's 50 over 64 because the X squareds cancel. In lowest terms, 25 over 32. And that's it. Yeah, so 11 is B. The players on a basketball team made some 3-point shots, some 2-point shots, and some 1-point free throws. They scored as many points with 2-point shots as with 3-point shots. Their number of successful free throws was one more than their number of successful 2-point shots. The team's total score was 61 points. How many free throws did they make? So the 3-point shots, 2-point shots, and 1-point free throws, I will call A, B, and C. And the score for the 3-point shots obviously is 3 times A, and they're saying it's equal to the score with the 2-point shot, so it's equal to 2B. And the next piece of information is that the number of successful free throws, which in our case is C, is one more than the number of successful 2-point shots, so it's basically equal to B plus 1. And then the last piece is that their total score was 61, so that means that 3A plus 2B plus 1C is equal to 61. So what are we asked to find? How many free throws? So they want you to find the value for C. Okay? Well, in this equation, we can substitute our findings. 3A is 2B, so I can just put that there. 2B, I'll just leave that as that. And then this 1C, which is just C, I can substitute B plus 1. And that allows me to solve because I have just one variable now. So this is 5B. Bring the 1 over, and that would be 60. And therefore, B is 12. And then solving for C, C is equal to B plus 1. So that's 12 plus 1, which is 13. So number 12, the answer is A. How many even integers are there between 200 and 700 whose digits are all different and come from the set 1, 2, 5, 7, 8, 9? So the numbers are anywhere from 201 to 699 inclusive. Now we have to create a 3-digit number, obviously, and that has to be even. Okay, so if it's even, the last digit from this set is going to be either a 2 or an 8, because the last digit must be that in order for the number to be even. So these are our scenarios. Either it's a 2 or it's an 8. So let's talk about each of these. The first number, what can that be? Well, it's got to be either 2, 3, 4, or 5 or 6, right? Because the number is between 201 and 699. Well, the 2 from that set is already taken. I've already placed it here, and I can't use it again because all the digits are different. Well, okay, that's fine. Not a problem. But what about the 5? Sure, the 5 can go here. But that's it. 7 can't because the number only goes up to 699. So there's really only one choice for the first number if the last number is 2. And now, of course, I've got to choose the middle digit. And for that, I can put either a 1, a 7, an 8, or a 9. So I've got 4 choices for that number. So I've got 4 choices. So there's 1 choice here, 4 choices there, and then 1 choice here because that was fixed as a 2. So there's 4 right there. So 4 possible numbers of that form. Now let's talk about when it's 8 as the last digit. If it's 8, so that one's taken. So what can I put for my first digit? Can I put 1? No. Can I put 2? Yes. 5? Yes. I can't put 7 or 9. So I can either have a number like that, or I can have a number like this, 5 blank 8. So each of these, let's talk about it. If I have 2 and 8, those 2 numbers are taken. So this number can be either a 1, a 5, a 7, or a 9. So I've got 4 choices there. 1 choice for here because that was fixed as a 2. 4 choices there, and 1 choice here. 1 times 4 times 1 is 4. And in a very similar way, this guy, if my choices are between the numbers that are remaining, because the 5 and the 8 have already been placed, that number can be either a 1, a 2, a 5, or a 9. Sorry, a 1, a 2, a 7, or a 9. So that means I've got 4 choices for this number, 1 choice there because that's fixed, and 1 choice here. So 1 times 4 times 1 is 4. So I got this 4, this 4, and this 4. That is a total of 12. So number 13, the answer is A. A pair of standard 6-sided fair dice is rolled once. The sum of the numbers rolled determines the diameter of a circle. What is the probability that the numerical value of the area of the circle is less than the numerical value of the circle's circumference? Okay, so let's talk about that sentence right there. The numerical value of the area of the circle, which is pi r squared, is less than the numerical value of the circle's circumference, which is c for circumference. Well, c can be written as pi times diameter, or it can be written as pi 2r. So I got pi r squared is less than pi 2r. Now, the pi's cancel, so I'm just left with r squared is less than 2r, and then I can divide through by r, and that will leave me with r is less than 2. So that nicely summarizes into that inequality. But remember, we are talking about diameter here. So that no problem. Diameter, therefore, since diameter is 2 times the radius, diameter is less than 4. So the diameter must be less than 4. Those are the only sums that I can count in my probability. Now let's go back to the first part of the question. You got this die and dice, I should say, 2 of them, right? There's a pair, and you're rolling them, and then you will want to count the sum. So as always, since there's not that many, it's only 6 times 6, which is 36. I'm just going to write them all out. Makes it easier for me to explain. So these are the possible combinations, right? So now what we can do is very quickly add up the sums, because it's the sum of the numbers that we have to look at to see what the diameter of that circle will be. So I'll just write out all the sums. And now let's talk about how many of these sums create a diameter less than 4. Well, there's not that many. This one, and this one. I think those are the only ones where the sum is a number less than 4. And that's it. So of the 36 possible sums, or 36 possible, not sums, but the 36 possible outcomes, I should say, when you roll the dice, only 3 of them are less than 4. So that means 1 over 12 is the probability. So number 14, the answer is B. Roy bought a new battery gasoline hybrid car. I actually have one of these. It's called the Hyundai Ioniq. So I'm definitely well versed with these types of cars, and it's a great car. Okay, let's talk about the question now. On a trip, the car ran exclusively on its battery for the first 40 miles, then ran exclusively on gasoline for the rest of the trip, using gasoline at a rate of 0.02 gallons per mile. On the whole trip, he averaged 55 miles per gallon. How long was the trip in miles? So for the 40 miles that he drives, initially, it's using 0 gas. And then later, I don't know how many miles he drives, but let's just say it's X. And they give you sort of a gallons per mile type of number. And that's 0.2. So if I want to figure out the average, obviously I have to take the sum of the distance and divide by the total amount of gallons. Now the total amount of gallons, if this is X miles, and this is 0.2 gallons per mile, it would be 0.02 gallons per mile times X miles. And that would give me how many gallons? And it's 0.02x. This is the number of gallons. And that's what you put in the denominator here, 0.02x. And they tell me that average is 55. So this will allow me to calculate x, and then I can add it to 40 to figure out the total distance. All right, so cross multiply and you get 1.1x, and that is 40 plus x. And therefore 1.1 minus x is 0.1x. And then 40 divided by 0.1 is 400. So this x is 400. So that means the total trip was this 400 plus the 40. So that is obviously equal to 440. So number 15, the answer is C. Which of the following is equal to the square root of 9 minus 6 root 2 plus the square root of 9 plus 6 root 2? This is a very interesting question because you are not allowed to use a calculator on the American mathematics competitions. If you could use a calculator, then this would be absolutely no problem, but you're not allowed. Okay, so what do? What you do is you square it, and then at the end take the square root. It's kind of counterintuitive, but we have to somehow try our best to get rid of these radicals. Okay, so let's square this. If you do, I'll get 9 minus 6 root 2 plus 2. Let's see, 9 minus 6 root 2 times 9 plus 6 root 2. And then this will give me 9 plus 6 root 2 like this. And then this cancels with this guy up over here. So that would leave me with just 18 plus 2. And now what's inside the radical, that can be multiplied by each other. So 9 times 9 is 81. And then because it's minus plus, the two middle terms will cancel. and then you just get minus 6 times 6, 36 times 2, 72. And I drew that radical a little bit too long. Okay, so this is what we're down to. 18 plus 2, 81 minus 72, 9. So square root of 9, which is 3. So 2 times 3. So 18 plus 6, 24. So n squared is 24, but we don't want n squared, we want n. So it's the square root of 24. And square root of 24, let's see, 6 times 4, right? So that's 2 root 6. And 2 root 6 is choice B for number 16. In the 8-term sequence A through H, the value of C is 5, and the sum of any 3 consecutive terms is 30. What is A plus H? So we have A, B, C, D, E, F, G, and H. Okay, they just give me that C is 5, and that's it. And then the sum of any 3 consecutive terms is 30. So that means that A plus B plus C is 30. So that means since C is 5, A plus B must be 25. And although it doesn't necessarily mean this, I could just break it up. Let's just see if this works out. 12.5, 12.5 plus 5, that would be 30. Okay, if that is the case, then these 3 consecutive integers have to add up to 30. And the only way that's going to be is if this is 12.5, right? 12.5, 12.5, 25 plus 5. And then in a very similar way, these 3 integers have to add up to 30. And the only way that's going to be if that's 12.5. Now, these 3 integers have to add up to 30, and that means that has to be a 5. These 3 integers have to add up to 30. That way, this is 12.5. And then finally, the last 3 have to add up to 30. And the only way that's going to be if that's 12.5. So they want A plus H. Well, A is 12.5. H is 12.5, so therefore A plus H is 25. So number 17, the answer is C. Circles A, B, and C each have a radius of 1. Circles A and B share 1 point of tangency. Circle C has a point of tangency with the midpoint of AB. What is the area inside C, but outside circle A and circle B? This is obviously at the heart of the question, so I wanted to blow it up. Several techniques, but there's one technique I always use. Is we obviously have to find the area of the shaded region. So without going into super detail, I can immediately tell you that it's going to be the area of a circle minus, obviously, these regions right here. So I've got to subtract those regions, but what I'm going to do is cut them in half. Like this. And I'll call them whatever. I can just call them R for region. Like that. So essentially, probably not the best choice since R is radius. So let's just choose P. Doesn't really matter what you choose. Now, obviously, the area of the shaded region, AS, will be pi r squared minus 4P. So if I can figure out the numerical value of P, I'm set, because they told me that the radius is 1, so this just becomes pi minus 4p. Now let's concentrate on trying to figure out p. To figure out p, I will look at this region right here. Draw a line from A to that point, and draw a line from A to this point. That is obviously a quarter circle. So to figure out p, it would basically be the area of a quarter circle, and from that, I will subtract this triangle. If I do that, I will get the value for p. So p is the quarter circle, so pi r squared divided by 4, minus that triangle, which is 1/2 base times height. The base and the height are both the radii of the circle, and those are both 1. So 1 times 1. And r is 1, so I can put that in here also. So it just becomes pi over 4 minus a half. Yeah. So now I just go back and plug it in here. This is p. I can actually do 4p down here. It makes it a little bit easier. That's going to be pi minus 2, right? Yeah. So then plug it in here. pi minus 4p, which is pi minus 2. And that means it's going to be pi minus pi plus 2. The pi's cancel, and you're just left with 2. So the answer, interestingly, is the only one that does not have pi in it. And that is C for number 18. In 1991, the population of a town was a perfect square. 10 years later, after an increase of 150 people, the population was 9 more than a perfect square. Now, in 2011, with an increase of another 150 people, the population is once again a perfect square. Which of the following is closest to the percent growth of the town's population during this 20-year period? 1991. I was in high school back then. The population, I don't know what it is, so I'll just call it n squared because they're saying that it was a perfect square. 10 years later, in 2001, it's now more 150. Population has increased by, but they're saying now it's 9 more than some perfect square. So obviously it's a different perfect square, so I'll call it m squared, and it's 9 more than that. And then 2011, now it's n squared. We're adding another 150 people, so we're up to 300. And now is once again some perfect square, so k squared, let's say. Okay, now I'm going to concentrate on this equation right here. What I'm going to do is subtract them. So m squared minus n squared is obviously 150 minus 9, which is 141. Now, some of you might be able to figure out which two perfect squares differ by 141. If you can't, not a problem. Just factor this. It's m minus n, m plus n. And then factor 141 into its prime factors, and I believe that would be 3 times 47. So that means that m minus n is 3, and m plus n is 47. If you add them, you get 2m is equal to 50, and therefore m is 25, and therefore n will be equal to 22. So there you go. If n is 22, that means in 1991 it was 22 squared, the population, and that's 484. And then in 2001, it was n squared plus 300, which is 484, plus 300, which is 784. So these are our two populations that we have to compare. What is the percent increase? Well, to do that, it's just 784 minus 484 all over 784. And that's 300 over, this should be 484 in the denominator. So 300 over 484. And that's going to be 62%. So number 19, the answer is E. 2 points on the circumference of a circle of radius r are selected independently and at random. From each point on a chord of length r is drawn in a clockwise direction, what is the probability that the two chords intersect? All right, let's talk about this. Draw a big circle here. So I've got my first point, and I draw a chord of length r. Now r is the radius, so the radius is approximately that distance, right? So I've got to draw a chord of approximately that distance. So let's call this point 1. Now I'll call this point 2. And again, I'm going to draw a chord in the, clockwise direction. So something like this. But these two chords don't intersect. They're not even close to intersecting. Okay, let's go back to the drawing board. And let's see what we can do to try to make them intersect, and that way we can understand the question a little bit better. First, let's draw a radius for a comparison. And therefore, if I'm going to draw a chord that's approximately the length of the radius, it's approximately that length. Now, I've got to draw another chord that intersects. The only way that is possible is if that chord is starting from a point that is in this region, and I'll show you. If this is P1, if P2 is here, you notice that the chords don't intersect. But once P2 starts in this region, it will. So for example, if P2 was here, then that chord will intersect. If P2 was here, that chord obviously will intersect that one. Similarly, if P2 is here, it will intersect. So as long as P2 is in this region, and I'll shade that region in red, from here to there, it will create two chords that intersect each other. So we have to figure out what percentage of the circumference is that. Okay. How do you do that? Well, this is the center right here that I just drew earlier, right? This was the center. So from the center, I will connect lines to the edges. So first line to that one, then to here, and then let's connect that. Now, the most important thing, in my opinion, about this question is that those chords are of length R. So this is R, and this is R. But from C to the edge, that's R, and that's R. So that means these are equilateral, and therefore this is 60 degrees, and that's 60 degrees. So that means this segment of the circumference is 120 degrees. 120 divided by 360 of the circumference, which is basically 1/3. As long as you're within that 1/3 of the circumference, you will be able to produce two chords that intersect. And that's it. That's the answer. So number 20, the answer is D.